Okay, so there were some questions about the tree on page 179, the recursive calls, okay, on QuickSort. So I thought it would be worthwhile to go through this example in more detail. So here I'm in Excel, which is one of my favorite tools for numerical things. And when we start off, okay, so the QuickSort or the other, what's the other, quick select, whatever the other, it's not Lamuto, it's what the other sort is called. You could do Lamuto on this, but in this case, we're doing the other one, okay, which tracks both positions with that I and J. Okay, so the way this works basically, this is our initial position. We have our, these are the positions, okay, of the array. Okay, so I could probably go ahead and make those. Let's make them red just so we're clear. These are array positions, and this is what we have in the array. Okay, so the first step on this sort is to make the first element our pivot point. Okay, we're then going to move I all the way until we find something bigger than 5. Okay, so I is there, we move I there. Okay, we moved that because 3 is not bigger than 5. 1's not bigger than 5. We get to 9. 9 is bigger than 5. Okay, so we're going to stop there. Okay, the Lamuto, that's it. We've gone to the next. We would then swap those out and go from there. Okay, but on the other partitioning, the quick select, I think, should look that up, shouldn't I? Anyway, the other one, the one that Hor did. Okay, we're now going to go from the right as well. So we're going to start with this J here. Okay, and we're going to keep moving left with the numbers until, so we want things to the left here to be bigger, or sorry, to the right here to be bigger than 7. Okay, that's the position we're moving from there. Okay, so in this case, we're looking for things that, things that are big. I'm going the other way around. This is why it's confusing. When we're moving to the right with the I, we're looking for something bigger than our pivot point 5. We're moving from the left, we're looking for something smaller than our end point. Okay, so we're going to keep everything to the smaller things to the left. Okay, so we move here and we found it. Okay, that this is correct. This is where this is now smaller than this. So we're now at that point. Okay, so at that point, we've completed the first part of this partition. Okay, and we now need to, let's see, we're going to keep moving. We're going to swap these positions. Okay, so this 9 becomes a 4, and the 4 becomes a 9. Okay, everything else exactly the same. Need to make my other letters bigger here and other numbers bigger so we don't look funny. Okay, so we've swapped these out. These remain the same. Okay, so we can copy all this down just like we were. Okay, copy this down and copy this down. Okay, so we're still in this line over here. Okay, we're still in this step 1 here. Okay, and we're checking to see if L is less than R. Okay, and in this case, the L and the R are just the I and the J. Okay, that's really what we're looking for here. Okay, so we're now going to start this up again. Okay, so I'm here and I'm looking for things that are bigger than the pivot point. Okay, so I move I to here. I found it. Okay, I'm now here. I'm moving for things that are, why are there different numbers there? Let me see. I'm missing a number entirely. That makes no sense. Oh, that's not a 5, that's a 2. That's what's wrong. Okay, easy enough to fix. Yeah, that was position 5. Okay, so this one is at 9. This one moves over to here. Okay, so now J is here. Okay, and this number, we can't go any further, or it doesn't matter. It's the first one that's smaller than the 7, and this is the first one that's bigger than the 5. Okay, so at this point, we swap these two out. Okay, when we swap them out, we're going to take, that's going to become a 2. and that's going to become an 8. Okay, the 9, 7 are still the same. And then all of this didn't change from this row down. Okay, that's not what I wanted to do. That's not what I wanted to do. There we go. Let's try it again. There we are. Okay. So at the next step here, when we go to move things, okay, the J is going to move to there, and the I is going to move to there. Okay. At that point, from the quick select, we've crossed. Okay, those two have crossed, which means that we now have done what we wanted to do, that all of the numbers to the left, starting with J and going left, are less than the pivot, and all the numbers to I moving to the right are greater than the pivot. Okay. At this point, we set S, the split position, to be here. Okay, so this is a position that shows where we're going to make the split. Okay, so we're then going to switch out the 5 and the 2. Okay, so we're going to do the 2 is going to come over here. That's still a 3, 1, 4. The 5 is there, 8, 9, 7. Okay, and we've now done this step, and we have found that the S from here is equal to 4. Okay, which means we're then going to quick sort on from the left here all the way up to 3. Okay, so that we're going to copy down here the 2, 3, 1, 4. That's what we do first. Okay, so that's where the recursive call happens. We're in quicksort, we call quicksort again. Okay, so to do this, we're going to bold that one. We're going to set the I back to here, and we're going to set the J to the end there. Okay, so we're now looking for something from this position. Okay, we're going to move. We already get something bigger than 2, so we stop. Okay, so I is done. We don't move I anywhere. We go here, and we're going to move J over 1. Okay, and we immediately find something that's smaller. Okay, so we then switch those positions. So we get a 2, 1, 3, 4. Okay, that's still bold. Okay, when we try to go one more time, okay, we're just going to switch the J with the I to try. Okay, so we've now got that part done. Okay, so we've made this next. We've made this. So again, so on the recursive, when we hit this line, all this starts again. It gets its own other version. Okay, so we're now on this S for the second time. Okay, and when this crosses the second time, the S is equal to 1. Okay, so this is in the picture that the book has. All of this up here is what we do at that first tree node, okay, where I is equal to 0 to 7. So we're going 0 to 7, and we return our S equal to 4. Okay. When we then call quicksort again, we have a whole new version of it. We start back up at the top. Okay. And in this one, our I is equal to 0, and our J, or it's gotten left to right. L is equal to 0, R is equal to 3. Okay. And then we're going to get our S here being equal to 1. That's the split position there. Okay. So the second time we run this, we get our S being equal to 1. Note, we still have not sorted the second half. Okay. We're going to come back to that in our recursive calls. Okay. So we've done this. We're now going to make the switch here and go from the 2, 1 to the 1, 2. Okay. With the 1, 2, okay, we're now doing the I is equal to 0, R, no, we're doing the R is equal to 0. Yeah, that's interesting. I don't know why. There should be another step here. They're just showing it going from here directly to just having 0, 0, where there's just 1. Okay. Which is what's going to happen because there's only 2. Okay. Once we've done that part, okay, so now we're on whichever version of it we are, we have to go back and do the 3, 4. Okay. So we're going to drop down the 3, 4 there. Okay. And then when you run that one, you're going to end up with the 4 there. Okay. And you now have, for this part of it, as we're keeping track here, 1, 2, 3, 4. That's been sorted. Okay. But we're not there yet. I mean, that's still there, but we're still have the other part to do. Okay. So now we've made it down the left tree as far as we can go. We came back up and did the I is equal to 2 to 3, and then the I is equal to 2 to 1. Okay. And then the 3, 3 just takes itself out. That's when we were at 4 down to 4. That's the 3, 3. Okay. We can now go back up. We're now to the node that's to the right of the root node, going from 5 to 7. Okay. So positions 5 to position 7. Okay. So we know that 5's in the right spot. So we're just going to do the 8, 9, 7. Okay. And that's going back to the first time that we ran this quicksort. And that's just how the recursive things work. Okay. Then from the 8, 9, 7, we're looking for the 8 to be the pivot point. Okay. Where our I and our J, I is going to be here, J is going to be there. Okay. When we do that, we're going to end up with, when they switch, okay, the 8, 7, 9. Okay, so we have to flop that because the I is going to, the I is not going to move, but the J is going to move. Okay. So we're going to have the 8, 7, 9 switch. That's really all there is to it. As far as that goes, we've now crossed. So the J is here, the I is there. Okay. So on this one, the new S is going to be equal to 6. Okay. So we swap these out to the 7, 8, 9. Okay. And then we get the one that is 5 to 5, which is the 7. On that half, we get the 8, 9. I guess it's a different line. The 8, 9, where we have our pivot point there, which comes down to the 9. Okay. So when all said and done, we end up having here 1, 2, 3, 4, 5 from all the way up here. 7, 8, 9. Okay. And that's how that works. Okay. So hopefully that's clear. So to do this, we have to call QuickSort. Every box to call to QuickSort. Okay. Hopefully that helps out. If you still have further questions, make sure you ask me tonight at our office hours.